Today we are going to discuss the velocity analysis of a slider crank mechanism. So the question is, in a slider crank mechanism, the length of the crank OB and connecting rod AB are 125 mm and 500 mm respectively. The center of gravity G of the connecting rod is 275 mm from the slider A. The crank speed is 600 rpm clockwise. When the crank has turned 45 degree from the inner dead center position, determine the velocity of the slider A, the velocity of the point G, and the angular velocity of the connecting rod AB. So this is your question, and I hope you have understood the previous session. So what is a slider crank mechanism? So this is actually simply a slider crank mechanism. So this is your slider, this is your cylinder, which is a fixed one. The slider is moving inside the cylinder, and this is the origin or the crank center. This is your crank center, and this is actually a fixed position. I'm just naming this is the origin, this is the B, and this is the A, the point A, and this is again a grounded point D. Okay, here OB is the crank, OB is the crank, BA is the connecting rod, then here A is the slider, and D is the cylinder, which is a fixed one. Here origin O is also a fixed one. And so considering a cylinder piston arrangement, this is the IDC or inner dead center, and this is the outer dead center. So you can see that this is the configuration diagram or space diagram. So in that you can see that the crank is rotating at a 600 rpm. The crank is rotating at 600 rpm, and the crank length is 125 mm. Crank length is 125 mm. Then the connecting rod AB is of 500 mm, in which G is located 275 mm far from A, the slider. Okay, so we can see that the crank is rotating in a clockwise direction, and this is the IDC, and here it will be the IDC, and here this will be the ODC. The slider and the connecting rod will be in a straight line. Okay, from that particular position, the crank has turned 45 degree from the inner dead center position. Okay, so this is actually the configuration diagram. Now we are going to enter the values in a tabular column. The link name is OB, then AB, then slider A, after that the origin O, which is a fixed one. Okay, then next you have to find the velocity of this point G, and again you have to find the angular velocity omega AB. The crank length will be 125 mm, so it will be 0.125 meter. The length of the connecting rod will be 500, so it will be 0.5 meter. So now we are going to draw the velocity diagram. So first of all, we need the velocity VBO. That means the velocity of B with respect to O, and we know that V is equal to R omega. So here R is equal to 0.125 meter into omega. Omega is equal to 2 pi n by 60. Okay, here the crank speed is in 600 rpm. Okay, 2 pi n by 60, which is equal to 0.125 into 2 pi into 600 divided by 7.60. Okay, upon solving, the velocity value will be 7.854 meter per second. Okay, so the velocity value will be 7.85 meter per second. So I am scaling it as 78.5 mm. Next I am going to find out VAB, okay, velocity of A with respect to B. So for that we have to draw the velocity diagram. First of all, we have to mark the fixed points. So here O and D is the point in which there is a cylinder, and cylinder is fixed. Okay, and slider is moving here. Okay, slider is moving inside the cylinder, and cylinder is represented as D, and D is the fixed point over there. Okay, so O and D are the fixed points, and you can see that the velocity VBO is perpendicular to the link OB. So I am marking the fixed point. From that point I am plotting the velocity VBO. Okay, I am plotting the velocity VBO. Next I am plotting the velocity VAB, which is perpendicular to the link AB. Okay, plotting the velocity. Next I have to plot the velocity of the slider. Okay, so velocity of the slider will be along the line of action of the slider. Okay, so here you can see that the slider will move along the line of action like this. Okay, so the slider will be moving like this, right? So I am just drawing the velocity vector along the line of action. Okay, okay, so I have got this point as B, this point as A, this point as A. O and D are the fixed points. Okay, so the velocity vector, direction of the velocity vector, so this is in this direction and this is in this direction. That means this is velocity of B with respect to O, this is the velocity of A with respect to B, and this is the velocity of A with respect to D or O, V A O also. Okay, upon measuring this value, we came to know that the velocity VAB is equal to 55.8. okay, 55.8 mm. So the velocity VAB will be equal to 5.58 meter per second. Okay, so next, the velocity of the slider. So upon measuring, it seems to be 64.6 mm. So the velocity of the slider will be 6.46 meter per second. Okay, so next you have to find the point G. Which is 275 mm from the point A. Okay, so here is your point A and here is your point B. Okay, somewhat in between this line, the point G is located. Okay, so for that you have to take the ratio. Okay, so the length AB divided by AG is equal to velocity AB divided by AG. So this value we have to find out. The value of AB is equal to 500, AG is equal to 275, which is equal to the value of AB from the velocity diagram it is 55.8 divided by the value of Ag. So from this, the value of Ag is found to be Ag is equal to 30.7 mm. So I am marking the value of Ag in this particular velocity diagram, and it will be somewhat over here, this point G. Okay, so this will be the point G. Next, what we have to find is the velocity of G. That means the velocity of G with respect to the zero velocity point, or the absolute velocity of the G. Okay, so for that we have to mark this, we have to join this line segment. Okay, so upon joining this line segment, the velocity, upon measuring this value OG, vector OG, the length was found to be 67.7. so therefore the velocity VGO, velocity of G with respect to O, is equal to 6.77 meter per second. Okay, so next we have to find the angular velocity. Okay, angular velocity omega AB. The angular velocity omega is equal to V by R. Okay, so here omega AB is equal to VAB divided by R. R is the R is the length of the link. That means here it is AB. Okay, so therefore omega AB is equal to, so therefore omega AB is equal to VAB. VAB is equal to 5.58 meter per second divided by AB. AB is 0.5, 0.5, and which will be equal to 11.1 radians per second. Okay, so these are the answers. So velocity of the slider is equal to 6.46 meter per second. Then the velocity of G is equal to 6.77 meter per second. Then omega AB, the angular velocity of the connecting rod, which is equal to 11.1 radians per second. So I'll explain it once again. First we have drawn the velocity. First we have marked the, I will explain the procedure once again. First of all, we have marked the zero velocity points O. Next we have plotted the velocity diagram. That means the velocity VBO. Okay, so this is your first vector. After that we have plotted the second vector VAB, velocity of A with respect to B. So this is your second vector. Finally your third vector. Then you have marked the point G. Then you have plotted the velocity of G with respect to O. So this is your fifth vector. Okay, so this is your procedure to carry out this velocity diagram or velocity analysis of a slider crank chain. Okay, so please try to solve the question. Thank you.